Welcome to Cyborg 86. Today we're going to build this semi, either in a box trailer format or a flatbed. Your choice. This is in approximately 1/43 scale. You can see I got the parts all laid out here, for the tractor anyway. We'll lay out the trailer parts in a bit. Got the electronics here too. Trying to use off-the-shelf parts as much as possible, so no special knowledge or electronics info required. And we got Miles here with us today. Again, as usual. Wait, Miles, you're looking awful pale, buddy. You doing all right, man? The cab prints in 3 parts with the sleeper, the cab, and the front clip. I already have it assembled here. You just glue it together, then paint it, add your stickers, and you're all set on that part. We'll add the exhaust stacks and the air filters and the fuel tanks, other accessories, a little bit later. The build file includes the chassis and the steering components and the rims and the accessories, things like that. But you will need some hardware. Several 1.4 millimeter screws in a couple of lengths, some 2M screws, some bearings, and a paper clip. Well, let's make some room and get started. Today I'll be using electronics off the Red Cat Ascent 18. I usually use a small battery like this, but today we're going to use this big one. That'll work on the box trailer, but it won't work if you build a bobtail or a flatbed. You'll need a small battery if you do that. Here I fit the receiver speed control combo from the Ascent 18 and a small battery inside, and it's going to work just fine, I think. Use a little servo tape or maybe some sticky tack to attach it to the sides, and you should be able to get to the cords without pulling anything out. And the servo sits up front in the cab while the electronics go in the sleeper. While the electronics work is minimal, you will need to do some soldering. The N20 gear motor in the picture does not come soldered, so you need to solder a wire to the motor. What I'm doing here is a test, and you want to make sure that the motor is rotating the correct direction before you begin assembly. The motor will be oriented towards the front of the cab, so you want to make sure that the top of the shaft is rotating toward the motor. That'll give you forward motion once you get it assembled. If it's rotating the wrong way, just flip it over and take note, make sure you install it that direction. If you get it wrong, you can resolder it, but it's easier now. And if you're putting the electronics in the bed, you'll need some extra wire and make it extra long. You want some nice, light, flexible wire. If you're putting it in the cab, then you just need short wire, of course. Oh, sorry, Miles. Yeah, here. Just hang on to that, all right? Now, a special note about mounting the motor. These have holes in them for 1.4 millimeter, but they're described as loose. And they're very loose. They do not bite at all. However, I've designed the chassis with a little bit of offset, and when you put both screws in at the same time, it'll bind against the motor, and it'll fit right in. You'll see. Remember to install the motor the proper way up so you don't accidentally reverse the rotation. Now let's install a couple 1.4 millimeter screws into the chassis. They need to be 8 millimeter long in order to bite in good on this side. The other side will actually need to be shorter, or the two will meet in the middle. Just get them started and don't run them all the way through. Now we can put the motor up next to it and do the hard work. This is one of the hardest parts of the whole assembly. What I do is hold it and kind of monkey with it, work one screw in a little ways till it's going into the hole, about a third of the way, maybe half, and then I move to the other screw, work that one in, make sure it bites good. Now it may press out, you might have to back screw out a time or two, but if you keep working it, you'll get it, and it'll hold super solid. Yeah, what I tell you, look at that grip. That is on there. The next side's the same, but you want to use a 5 or 6 millimeter screw. Again, they're 1.4M. Next are 4 screws that go down the side. These will be the 5 or 6 millimeter. Either one will work. Okay, Miles, hand me that servo now, would you? Let's go ahead and put this servo in. You want to put the servo horn towards the front, and you're going to put the servo on top of the chassis rail, just like that. We're going to jump ahead for a minute and talk about tires. I have these little toy tires on there right now. These are cheap and plentiful, but there are some other options out there I'm working on. This tire is very soft, as you can see. It's off the LDARC X43 crawler. They're about $7 for four of them. And this one's a Lego tire. And it fits about the same diameter, but you can see it's a whole lot wider. Might be good for a 10-wheeler, but for the fronts, I think we'll probably have to split one in half. I'll work that out and let you know. Either one of these tires is going to work better, I think, as far as grip and suspension and smooth rolling than the toy tires I have on there now. But today I'm doing the toy tire build. Before we get back to the chassis, let's go ahead and talk about these wheels. These are for the toy tire build, and there's a few different rims that you need to know the difference. The dually on the left has a D-shaped hole in it, and that is so you can mount it to the motor. On the right, you see the larger hole, and that's so it'll hold some bearings. These toy tires have a lip on one side that they don't have on the other, and the rim is designed to mount it corresponding. So just make sure it's oriented right before you push it on, and just kind of work it on. The bearings I use are 2 by 5 by 2 millimeter, but the 2.5 width will also work. Now you can't put them in from the backside, and you put them in from the front because they print on the backside and that first layer always squishes down a little bit. So it's much better to put them in from the front, and then that squished down layer helps them keep from sliding out the back. You can use whatever method you think best to press that bearing down in, but I like to use the back of my hobby knife. Just be careful. Anyway, you gotta get it lined up in there and then give it down a good shove. But every printer's different, every filament's different, and sometimes it doesn't want to press in. And in that case, you might take your hobby knife, put it down in there, and chamfer the hole just a little bit to help it get started. This has always worked for me. And if it's really stubborn, sometimes you really gotta give it a shove. Maybe even turn it sideways, give it a good grab, just shove right down on that thing. Okay, seriously, don't put your hand on the blade of a hobby knife. Try a drill bit instead. All right, now I think it's gonna go in a lot better. As I said, every print is different, and sometimes even the bearing sizes vary just a little bit. So this may or may not be necessary. Every wheel has two bearings, so make sure you put them both in. This will keep them rolling nice and smooth. Now let's go ahead and set up the steering components. We have a cross member, a drag link, and two hubs. The M1.4s in a 6 millimeter length will work just right. 5 should work too, especially on the drag link. I try to avoid using supports as much as possible, but the hub needs supports, so you may need to do a little sanding and cleanup work on that. Since taking this footage, I've modified the tolerances on the hub clearance, and they turn a lot smoother now. In fact, they turn so sharp that you about make a drift semi out of this thing. Everything is symmetrical, so when you put the drag link on, doesn't matter if you put it on the top or the bottom. We'll make that decision when we install it to the chassis. And trust me, it's much better now. It turns a lot sharper in this and a lot smoother. So I think you'll be happy with it. I sure am. When you install it to the chassis, you want the drag link to sit on top of the hub arms. So up on top, not on the bottom. Now, some servos do differ. This is the Endura. So if your servo has a different rise to it, then you might want to put it on the bottom. So you have options. And speaking of options, when you mount the rear axle here, you have some options there as well. You can mount it tightly against the frame, which will lift the rear axle up a little higher so it's not rolling or touching the ground. You can also mount it loosely so it'll roll freely, or you can shim it and mount it at the same height as the drive axle. But if you do that and you go over some bumps or something, it can lift the drive axle off the ground and cause you to lose traction and you'd get stuck. So keep that in mind as you consider your mounting option. I'm choosing a longer screw here. I'm going to let the rear axle roll freely. There will be a little wobble to it, but I'm willing to put up with that to see the wheels turning. Now we're going to pick up the dually rim, the one with the D-shaped hole in it, and we're going to mount that to the motor's axle there on the transmission. It's a press fit, so you may need to press a little, you may need to chamfer it a little bit. Now we'll use one of the M2 screws and we're going to take and put the front rim on. It has 2 bearings as well, and we'll just mount it right to the hub up front there. Just tighten it down until where it's just snug. If it doesn't spin freely, you back it off just a little bit. I've actually improved the front hub just a little bit since making this video as well. Has just a little bit more clearance and spins even better. And we'll do the same thing on the rear. At this point, I'm adjusting the free float of the rear axle. This illustrates what I'm talking about. If I run over a small bump, the front axle will go over it fine, but if the rear axle isn't free floating, it'll hang up on that bump and lift the front axle off, and you'll be stuck on this tiny little bump. So, like I said, you got options. Now that the wheels are installed, we can go ahead and throw on the bumpers. They each have 4 holes for 4 screws, but you really only need 3. Just need the third one to keep it from pivoting. The front of the cab will just sit on top of the front bumper when we get it all done. For steering, I just put a screw through the bottom of the servo horn and then line it up with the slot on the drag link. Just watch that the screw doesn't go through so far that it hits the frame rail. And here's this pretty rear bumper again. Doesn't that look nice? Oh, sorry, Miles. Got you again. Hang out over here a while. Sorry, Miles. Since I'm putting the electronics in the rear, I'm routing the wires back so I can get them back to the trailer. If you're routing the wires to the trailer like I am, there's a little spot for you to screw a paper clip right behind the sleeper. You can use that to hold and route the wires. Now let's make this thing look nice. We'll go ahead and add on the air filter and the tanks and the steps and the stacks and all those things that make it look like a semi. I'll just speed through it, you can watch. You can find this little glue cup that I use out on Thingiverse or Maker World. Just something I whipped up to help apply the glue right where I want it without using the whole bottle. The signal lights on the fenders are very small, so you might have to drill out a hole there, make them fit just right, then glue them in. There are 4 holes that can be used to mount the body to the chassis, just using the 1.4 screws. You can use all 4, or you can just use 2, or even just 1. And if you want, you can just set it on there. There's a little bit of a pressure fit, so if that works, that would be my preference. And the front just sits on the bumper, so no attachment at the bumper. In case you were wondering, my hand is just fine. That red's just a little bit of paint from the Band-Aid that I made look like an injury. Little slapstick comedy. This video is getting a little bit long, so I think I'll save the trailer build for another day. That video will be much shorter, I'm sure.
Well, are you happy? Are you feeling alright?
We'll just go ahead and say goodbye to Miles and call it a day. And remember to like and subscribe. Miles? Why is your hand bandaged? You didn't grab the wrong end of the hobby knife, did you? Yep.
And everybody